Welcome to McPlum, simple solutions served daily.
You start by collecting the audio and selecting a model. You need a dry lead vocal and a target reference singer clip for tonal direction. Once you have files, install Python 3. 9+, set up a virtual environment and install model requirements. Make sure your GPU drivers match CUDA. If you're short on GPU, pick a lightweight model or use Cloud Rent. This initial preparation gets you into the pipeline quickly, without wasting time on needless setup. Next, preprocess and feed the model. Trim silences, normalize levels to about -23 LUFS, resample to the model's required 16K or 24K. Once done, create embeddings from the reference singer and either fine-tune for a few epochs or run voice conversion inference. You'll monitor loss and listen to checkpoints so you can stop when it sounds right. When synthesizing, provide the source vocal and target embedding. Then tweak pitch shift and format controls to preserve expression while finally polish the output with post-processing. Apply gentle EQ, a de-esser for sibilance, and matching reverb to blend the voice into the mix. Once done, normalize or master to your target loudness and export a 24-bit WAV for highest quality. If you hear metallic artifacts or robotic textures, reduce extreme pitch shifts, increase inference steps or the model's denoising strength, and rerun the conversion. Make sure source audio is clean and well-aligned for best results.
Thanks for watching. Stay juicy and subscribe.